In this video, we'll solve problems related to the roots of complex numbers. For this problem, we want to find all of the complex solutions to z to the fourth equals root 3 plus I, and then see how they relate to the solution to z to the fourth equals 1. So because we have a z to the fourth here, we know that we should have 4 different solutions to this equation. How do we go about finding those? Well, we need to use the complex numbers in polar form to make this work. We first want to convert root 3 plus I into polar form. So the modulus here is the square root of root 3 squared plus 1 squared is square root of 3 plus 1, which is going to give me a 2. And the angle should be inverse tangent of y, which is 1, over x, which is root 3. And so this will be positive pi over 6 because sine is 1/2 and cosine is root 3 over 2. So this here is 2e to the I pi over 6. So now to find the fourth roots of this number, I can do it in several ways. I can follow the formula as it is, or I can think about what angles are equivalent to this one by adding 2 pi to it. So the formula would tell us that the solutions to z to the fourth equals root 3 plus I are of the form z equals the fourth root of 2 e to the I pi over 6 plus 2k pi divided by 4. So I'm taking this angle, dividing it by 4, and I'm adding 2k pi to give me equivalent angles that are otherwise around the circle to get this. Or by simplifying, this is 2 to the 1/4 e to the I pi over 24 plus pi k over 2, which I can rewrite as 2 to the 1/4 e to the I pi times 1 over 24 plus k over 2, or 2 to the 1/4 e to the I pi 1 plus 12k over 24. And I should have 4 solutions here, so I should get different values for k equals 0, 1, 2, and 3. So I get solution 1 as 2 to the 1/4 e to the I pi over 24 with k equals 0. My second one is 2 to the 1/4 e to the I 13 pi over 24. My third one is 2 to the 1/4 e to the I times 25 pi over 24. And the fourth is 2 to the 1/4 e to the I 37 pi over 24. If we were to add one more, I would add 12 more to get to 49 pi over 24, but that's the exact same as pi over 24 because 49 over 24 is just 2 and 1/24. So here are the 4 solutions here. The other way to visualize this is that the complex number root 3 plus I can write in several ways. So root 3 plus I we saw was 2 e to the I pi over 6, but that's the same as 2 e to the I 13 pi over 6 because 12 pi over 6 is just 2 pi. Same with doing 25 pi over 6, and same with doing 37 pi over 6. And if I take each of those and divide the angle by 4, I get exactly the 4 angles that I got in the previous part here. So they both get you the same set of complex numbers at the end. How does this relate to the solution to z to the fourth equals 1? Well, let's go back to this form here that we had for our solutions. For our solutions, so for z to the fourth equals root 3 plus I, the solutions were 2 to the 1/4 e to the I pi 1 over 24 plus k over 2. Or 2 to the 1/4 e to the I pi over 24 times e to the I k pi over 2. Now what happens for z to the fourth equals 1? Z to the fourth equals 1. This is the complex number 1 e to the 0, right? I0 pi. Or it's 1 e to the I times 2k pi for any k. So if I now divide this by 4, I get that my solutions here are z equals 1 times e to the I 2k pi over 4, or 1 times e to the I k pi over 2, which that exactly matches this part here. So we can think of solutions to this equation here as having a part that corresponds to the roots of unity from the equation here. It's this last bit here. there's a scaling factor based on what this number looks like, and there's a rotation factor in front. So if you look at the roots of unity here, the 1 e to the I k pi over 2, that's actually going to be just 1i, negative 1, and minus I. If I draw those on a set of axes, the purple ones, which are solutions to this equation here, are going to be 1i, minus 1, and minus I. And for our original equation, our blue one up here, for the root 3 plus I equation, those are going to be sort of taking these roots, expand them out a little bit by a factor of 2 to the 1/4, and then rotate by an angle of pi over 24. So they're going to be somewhere like, if I draw the spokes here, it'll be easier to see, 1, 2, 3, and 4. And for the new ones, they'll be something like 1, 2, 3, and 4. So the sort of fundamental root of unity here gives the basis of what the shape looks like, and then it's just rotated and scaled to fit the complex number there, because in terms of things in the plane, complex numbers really just are scales for radius and rotations for the angle theta. So you apply those things to your shape that you get for roots of unity, and that gives you the roots for this new version here for root 3 plus I. So that's how you would set up and solve this sort of equation here to figure out the roots of a complex number, as well as relate them to the roots of unity for the standard equation for c to the 4th equals 1.